class we will be discussing few more problems related to the different kind of reactor systems and their performance equations. Let's see, this is a problem which is discussing on related to one aqueous feed of A and B, two compound. 400 liter per minute is the flow rate, of which 100 millimole per A is there in a liter and 200 millimole of B is there in a liter, is to be converted to product in a Plugflow reactor. So please understand this aspect, it is important. The kind of the reaction is represented by A plus B equal to 1. So A and B is going to stoichiometrically 1:1 is producing product, and change of conversion of rate of conversion of A is second order. So 200 into Ca into Cb, it depends on both concentration of A and B, mole per liter per minute, it is given. Now the query is that find the volume of a reactor needed for 99.9% conversion of A to product. So essentially, before doing any solution approach, you already know this is a Plugflow reactor. So performance equation, the generalized performance equation, we should write over here. So for Plugflow reactor, we can write tau equal to Ca0, initial concentration of your feed, integration of dxa by minus Ra from x0. Essentially it is 0 only, but you are writing simply, and xa is the final conversion and Ra is the rate for the reaction. We already know this is 200 into Ca into Cb, but we need to understand this integration is in terms of x. You see, the differential form is related to x only, so we need to write the Ra in terms of x, not necessarily C and Cb. So we need to do those aspects before we are going to integrate it. So let's see what we are going to do. Initial concentration is given 0.1 mole per liter because 100 millimolar of A is given initial concentration, and B is also 200 millimole per liter is given. So we are writing Ca0, Cb0 values. Now at any time we can write Ca equal to Ca0 minus Ca0 Xa. It is very simple because this is the original concentration of this feed and Ca0 Xa is the degree of conversion. So concentration will definitely change depending on the amount converted. So that is actually Ca at any moment in a reactor system. So in for example, when we are discussing about Plugflow, so if I want to know what is the concentration of the feed at any point of time, we can calculate this concentration. Ca equal to Ca0 minus Ca0 into Xa. Similarly for Cb, we can also write the same expression, Cb equal to Cb0 minus Cb0 xb. This logic is very easy to understand because the concept, because if you see the volume expansion is not there. So at any moment, if we see what is the concentration in the reactor system at any moment or at any place we are discussing for integration, you can do the same process over here. So Cb0xb is the amount of B being converted. So it is easy to understand. Now in this case, if we do some changes, because we already know A plus B is producing R, so on the same ideology, if we move, we can know that this is the mole per liter terms. It's also mole per liter. So essentially this is, if your volume is constant, this also represent the amount, this also represent the amount. You know that amount of A consumption and amount of B consumption is same because A 1 mole and B 1 mole is equal. So then our integration will be more straightforward here, because tau equal to for CA0 and the conversion is 0 to 0.999 99% conversion, dxa remains same. Now minus RA is 200, CA we already shown, CA equal to, this is CA, CB this is CB, so we'll just substitute these two things over here, and CB0 CA0 those values are known anyway, so I can factor out CA0 0.1. Similarly CB0 I can also factor it out 0.1. Now this will become 1 minus XA and this will become 2 minus XA, because CB0 is actually twice of CA0. So that's all. So this simply arithmetic calculation you can essentially do. Remaining thing is only integration part is remaining, so essentially I'll show here. So just simplification of this one and this one, the division, all those aspects. Remaining is dxa 1 minus xa into 2 minus xa. So if we do the calculation part, our integration things, it is actually definite integral. This value is coming 6.2156. You can do your own integration aspect, and this value is coming 0.311. So essentially we are getting tau equal to 0.311. So tau you already know. What is tau? Tau is volume by flow rate. So volume is already known to us. Sorry, we are asking the volume, so flow rate is known. So tau equal to V by U equal to 0.311. U value is the flow rate value, meter cube or liter per minute. It is given 400 liter per minute. So that means we can plug it 0.311 into 400. So it is becoming 124 liter. So essentially the reactor can be, the Plugflow reactor volume can be calculated from the conversion data and the stoichiometry and rate expression for the system. So hope you understand this. And regarding this integration part, I will suggest you, because you see we can actually split into two different components. So we can make it like some constant divided by 1 minus xa plus another constant divided by 2 minus xa. So we're splitting this multiplication into two different groups, and then integration by parts is more easy for solving these kinds of problems. So this is actually mathematical aspect you should also know when you are going to do the integration. We'll be discussing another problem in this class again. This is a Plugflow reactor. You see, most of the problem till now we are discussing is related to Plugflow reactor. Plugflow reactor problem is that we have to do the integration. Unlike in this case of continuous step tank reactor or mixed flow reactor, where integration is not there, here integration is involved. Now see the problem. A Plugflow reactor of 2 meter cube processes an aqueous feed 100 liter per minute containing a reactant A, whose concentration is given initially 100 millimole per liter, and the reaction is reversible and represented by A to R, RA equal to 0.04 Ca minus 0.01 Cr. We have two parts of this problem. First, find the equilibrium conversion and then find the actual conversion of A in the reactor. So two aspects of this problem. Now first part is equilibrium conversion. So A is being converted to R and R is being converted back to A, and their rate expression is given. So when you say any equilibrium, that means concentration of A and concentration of R is no more changing. That means rate of change of A is 0. That is called equilibrium, right? So we'll do the same logic. Equilibrium means rate of change is 0. So if we put rate of change is 0 here, so we can say minus 0.04 C equilibrium A, 0.01 C of equilibrium concentration for R equal to 0. So essentially for CAE minus CRE equal to 0. Now CAE means equilibrium concentration of A, CRE means equilibrium concentration of R. We can write them very easily because we know the starting concentration of A is 100, starting concentration of R is 0. So we will use those information now. So instead of CAE we can write C0 initial C and how much has been converted, C0 into XAE. XAE is the equilibrium conversion. So that is very logical. C0 minus C0 XAE. So C0 is the total amount and this has been converted. So remaining is essentially CAE. Now CRE equilibrium concentration of the compound R, that is actually how much has been converted. The same amount has been converted to R, so C0 into XAE simply, and that leads to 4 into 1 minus XAE equal to 0, and we can solve it. So XAE equal to 0.8, that is the equilibrium conversion of A in any reactor systems. But instead we can assume this is the reaction which will happen in a batch mode, then we will reach conversion is only 0.8. Now we are going in a plug flow. Let's see what happens in plug flow. Plug flow expression you already know, that remain unchanged. So tau equal to Ca0 dxa minus Ra. Ca0 values anyway we know. Again minus Ra is the rate expression, that is in terms of Ca into Cr. As we have shown you, similarly you can write also Ca equal to Ca0 into 1 minus Xa, that is valid always, and Cr equal to 0.01 Ca0 into Xa. We plug this here. Ca0 value you already know, it is 100. So if we put the Ca0 values over here and just simplify, Ca0 values are no, so Ca0 is cancelled, and we can rearrange, it is becoming simply dxa divided by 4 minus 5xa. And I hope this integration is not a difficult one, we can do. So tau equal to V by U. U is the flow rate, right? V is the volume. So 100 0 to xa dxa 4, this one, if you do the integration, it will become 1 by 5 ln 4 by 5 minus xa. Now in this case we know what is the V. Volume is 2 meter cube and flow rate is 100 liter per minute, so I can plug those values here. So 2 meter cube means 2000 liter and this is 100 liter per minute. So this 100 is already there in your expression itself. So essentially unknown is only xa, so possibly you can solve it out now. Just rearranging, it is becoming ln 4 by 4 minus 5x equal to 1. So just exponential you do, then it is becoming 4 by 4.5 x equal to 2.718, and if we continue we will find x equal to 0.5056. So in this case we are finding the conversion value is actually 0.5056.